A warm good morning to my dear students. So now we will continue with the dynamics of particles, and we have been seeing kinematics of particles. We will continue with that. Now we will go and solve a problem here. Let me explain about the problem. Now a stone is dropped into a well, and the sound of splash is heard 3.6 seconds later. Now you have to find how far below the ground is the surface of water in the well, and assuming that the velocity of sound is 331 meter per second. So now what is given in this problem? The velocity of sound V is given as 331 meter per second, and the initial velocity U is 0. So when a particle is dropped vertically downwards, to start with, its initial velocity is 0. Now we will assume that the time taken by the stone to reach the bottom of the well as t, and depth of the well is given by h is equal to ut plus half into gt square, ut plus half into gt square. Now, since the initial velocity is 0, we are substituting as 0 and g as 9.81. We get h is equal to 4.9 into t square. Now, time taken by the sound to reach the top. So, from after the stone is dropped and it reaches the water, the splash is heard, and this the time travel stop. Now, equal to depth of the well by velocity of sound. So, velocity of sound is taken as 350. So, h by 350. So, h is given as 4.9 t square. So, 4.9 t square by 350. Now, it has been given in the problem that the total time taken is 3 seconds. So, what is the total time taken? Time taken by the stone to reach the bottom of the well plus time taken by the sound to reach the top of the well. So, that is equal to 3. So, 3 is equal to time taken by the stone to reach the bottom of the well is small t, and time taken by the sound to reach the top of the well is 4.9 t square by 350. Now, rearranging in terms, we get a quadratic equation 4.9 t square plus 350 t minus 1050 is equal to 0. Now, applying the quadratic equation solution formula, minus b plus or minus root of b square minus 4ac by 2a, and substituting 4.9 for a and 350 for b and minus 1050 for c, and we get the time as 2.9 seconds. Now, substituting this t value as 2.9 seconds, the value for h is equal to 4.9 t square by t, and we substitute, we get the answer as 41.21 meter. That is the total depth of the well is 41.21 meters. Now we'll go to another problem. A motorist is traveling at 90 km per hour when he observes a traffic light 250 meter ahead of him turns red. The traffic light is timed to stay red for 12 seconds. The motorist wishes to pass the light without stopping just as it turns green. Determine the required uniform deceleration of the motorist. Second one, the speed of the motorist as he passes the traffic light. Now, the motorist is traveling at a speed of 90 km per hour. We convert it into meter per second, which is equal to 90 into 1000 by 3600, which is 25 meter per second. Now, the time taken for him is 12 seconds. The displacement is 250 meters. Now, we are going to use the equations of motion. S is equal to ut plus half at square. V is equal to u plus at, and v square equal to u square plus 2as. Now, S is equal to ut plus half at square. If you substitute, 250 meters is the distance, and u is 2.5. The time is 12 seconds. Plus half into a into 12 square, we get acceleration as minus 0.6944 meter per second square. The negative sign indicates that he is decelerating. Now, the velocity is equal to u plus a into t. Again, you substitute u is equal to 2.5. And acceleration is minus 0.6994 into 12. We get velocity as 16.67 meter per second. So, which is nothing but 60 kilometer per hour. So now the speed is 60 km/h as he passes the traffic light. Hope you understood this problem. So by using the equations of motion, we could get the correct result, whatever is required. Thank you.